Hello everybody, so today I will talk about calculus. The topic today is about integration. So now I will show you the technique how to answer the integration from the question number 1 to the question number 18. So now I will answer about number 1. To ask, they go to with number 1 and ask to the power of negative number 3. So you will got about x square minus we have x to the power of negative number 2. So you got about negative number 2 plus 1 over negative number 2 plus 1, and we have c in here. So you got about positive 2x to the power of negative number 1. Now let's go to the second one. About this one, we got about x to the power of negative 5 over 4 plus 1 over negative 5 over 4 plus 1, and we put about c is about constant. This one you got about negative 1 over 4 over negative 1 over 4 plus c, and this is the answer for the question number 2. Question number 3, we need to use about substitution. So we put about u equal to the square root of 1 plus e to the power of x. So you got about u square in the both sides. So we cancel the square root. Later that we do first derivative in the both sides. You got 2u du equals to e to the power of x dx. So you got about the square root we change for u, e to the power of x dx we change for 2u du. So you got about number 2 in here, and you got about u square in here. So you got about 2u to the power of 3 over 3 plus c. About u, we change back for the square root of 1 plus e to the power of x. To the power of 3. And we have the constant in here. Question number 4, we use about substitution. So we put about u equal to 4x square plus 3. So you got about du equal to ax dx. Because we don't have the number 8 in here, so we divide both sides with number 8. About this one, you got about e to the power of u. X dx we change for du over 8. and we got about 1 over 8 e to the power of u plus c. About u, that's the about this one. Question number 5. We use about substitution. So we put about u equal to 1 over theta. So you got about the u equal to negative d theta over theta square. Because we don't have a negative in here, so we put a negative next to the u. So we got about this one we change for u. This one we change for negative du. Next, we put about 2 over 2 sine u cosine u. So because we have 2 sine u du or 2 sine u cosine u, you got about negative 1 over 2 sine 2u du. So you got about negative 1 over 4 cosine 2u plus c. About u, that's about 1 over theta. Next one, about this one, we put about u equal to tan 3 tan s to the power of 3 plus 2. So you got about du equals to 3 tan s square secant of s square ds. So we have number 18, we have number 3, so you got about number 6. We change for du. This one we change for u to the power of 2. So we got about negative 6 over u. About u, that's about this one. Next, about number 7, we put about s equal to tan t. So you got about the s equal to secant of t square dt. So we put about tan t in here. So you got about secant of t square in here. And we have tan t square in here. So this one you got about t. So we need to use about integration by parts. So we have two things. So we got about u equal to t, du equals to dt, dv equals to secant of t squared over tan t squared dt. So this one you got about v equals to negative 1 over tan t. So we got about u multiplied with v. Because we had a negative, so you got about the positive. And we have dt over tan t. This one we can put about cotan t dt. So about cotan t, we can change about cosine t squared over sine t, and we got the final answer. About t, dash is about s, so we change back for t equal to r time of s. So we put this one go back in here, here and here. So this one you can do by yourself. The next one, number 8, we use about integration by parts. So we have two things. So I put about u equal to arc cosine 2s. If we do du, negative number 5 over the square root of 1 minus 25s squared. About dv, that should be about s. So you got about v equal to s squared over 2. So we have u multiplied with v. We had a negative, so you got about the positive, and we put about 5 over 2, the integral of s squared over the square root 1 minus 25s squared ds. So I will concentrate about this one. So we need to use about integration by trigonometry substitution. So we put about s equal to 1 over 5 sine t ds equal to 1 over 5 cosine t dt. So we put this one in here, and we got about 1 over 25 sine t square. You got about 1 over 5 cosine t dt. So this one you got about 1 minus sine t square, because we just cancel 25 with 1 over 5 square in here. So you have 25 multiplied with number 5, you got about 1 over 125 sine t square cosine t. This one you got about cosine t dt. So we simplify cosine t in here. So we got about 1 over 125 the integral of sine t square. About sine t square, we can change about this one. One minus cosine 2t dt. We put number 2 outside, you got about 1 over 250, and we have 1 minus cosine 2t. So we got about 1 over 250 t, and we have 1 over 2 sine 2t plus c. About t, that should be about this one. So you got about t equal to arc sine of phi s. Now we can compile the answer. So we put this one in here. And we have 5 over 2 multiply with this one. Now we move to the next one. About number 10, we will use about integration by trigonometric substitution. So we put about y equals to 2 multiplied over the square root of number 5 tan t dy. You got about 2 over the square root of number 5 secant of t square dt. So we put this one in here. You got about 5 over 5 multiplied with 4 over 5 times t squared plus 4. And about dy, we change for this one. So this one you got about number 4. We put number 4 outside. So you got about 3 over 4 multiplied with 2 over the square root of number 5. That should be about, so you got about 3 multiplied with the square root of number 5 over 10 dt, because tan t squared plus 1 equal to secant of t squared. That's why they cancel on numerator and denominator. About t, we need to change back for y. So we multiply with the square root of number 5 and divide by 2. The question number 11. So we will use about integration by parts. So we have u equal to e to the power of negative 2s. So you got about du equal to negative number 2 e to the power of negative 2s ds. dv, we got about sine 2s ds. So we got about v equals to negative 1 over 2 cosine 2s. So we have u multiplied with v. Because we have the negative in here and we have the negative in here, so we have another negative in here, so they are still negative. 2 with 1 over 2, they will cancel. So we got about e to the power of negative 2s cosine 2s ds. So we use the same technique. dv, you got about cosine 2s ds. So you got about v equal to 1 over 2 sine 2s. So we calculate for this one. Because we had a negative, that's why I put negative in here. Because we have the negative, in here we have another negative, and we have negative this one, so we have the negative in here. 1 over 2 simplify with number 2, you got about e to the power of negative 2s sine 2s ds. And if we look carefully, this one is similar for the beginning, so we put this one is about capital I. So we got about I plus I in here. So that should be about equal to negative 1 over 2 e to the power of negative 2s cosine 2s negative 1 over 2 e to the power of negative 2s sine 2s. This one you got about 2i. So to get the value of I in here, we divide both sides with number 2. And you got about negative 1 over 4 e to the power of negative 2s cosine 2s negative 1 over 4 e to the power of negative 2s sine 2s. And we put about c in here. Now let's go to the next one, number 12. So we put about u equals to the square root of 3h plus 9. So we put the power 2 in the both sides. Later that we do the integral for the both sides. Because we don't have the number 3 in here, we divide both sides with number 3. So we got about e to the power of u. The h we change for 2u du over 3. So we put 2 over 3 in here. U du. So we can use about integration by parts. So we got about t equal to u. dt equals to du. dv, that's about e to the power of u du. So you got about v equal to the eu. So we got about 2 over 3. And we got about t multiplied with v and minus the integral of e to the power of u du. This one you got about u e to the power of u minus e to the power of u plus c. About u, that's about the square root in here. The next one, so we use about r equal to sine t, dr equal to cosine t dt. So you got about 1 minus sine t squared to the power of 5 over 2. This one we change for sine t to the power of a dt, or dr we change for cosine t dt. One minus sine t squared, you got about cosine t squared and 5 over 2 cosine t dt over sine t to the power of a. This one 2 and 5 over 2, we change for number 5 in here. So this one we can change about cosine t to the power of 6, and we have cosecant of t to the power of 2 dt. So in this situation we use about substitution. We put about z equal to cosecant cosine t dz equal to cosecant of t square dt with the negative, because we don't have the negative in here, so we put the negative next to dz. So you got about z to the power of 6 dz, and we have the negative in here, so you got about negative z to the power of 7 over 7, and z we change for cosine t to the power of 7 over 7. About t, that's about sine t, so we change back for t equal to r sine of r. So we put this one go in here. Now let's go to number 14. Z equal to tan s over 2. So we put about sine t equal to 2z over z to the power of 2 plus 1 cosine t equals to 1 minus z to the power of 2 over z square plus 1 dt equal to 2 dz over z square plus 1. So you got about dt is about 2 dz, and we have 1 plus z square in here. This one you got about 1 minus z square. Oh, sorry. To z, we have minus 1 plus z square over 1 plus z square. This one they will cancel. So you got about 2 dz over z square plus 2z minus 1. So in this situation, we add number 1 in here. That means we need to minus number 1. You got about negative number 2. So you got about z plus 1 to the power of 2 minus 1 minus 2. So we would about z plus 1 equal to the square root of number 2 secant of t dz equal to square root of number 2 secant of t tan t dt. So we change about dz for this one. So we got about 2 secant of t squared minus 2. So we have number 2 in here. We cancel number 2. And we have secant of t squared minus 1 is about tan t squared. So we have tan t. So you got about tan t in here. This one you got about secant of t. We can change about 1 over cosine t. Tan t, we need to change to sine t over cosine t. So this one we cancel. Now we just have 1 over sine t, 1 over sine t. We need to change about cosecant of t, and we got about negative of the square root of number 2 ln cosecant of t cotan t plus c. About t, we need to change back for this one. So we put this one go in here. So about z, that's about tan of s over 2. So we put this one in here. Now let's go to number 15. About this one, we put about s equal to 3 tan t dh equals to 3 secant of t square dt. So we put about 9 tan t square plus 81, and this one you got about 3 tan t. You got about 9 tan t square plus 9 to the power of 2. You got about the h we need to change to so we put number 9 outside. You got about 81. This one we change for secant of t square. So we have secant of t square in here, we cancel. So you got about secant of t square only. And we have number 3 and number 3. So we got about number 9 and we have 81, and we have 81, we cancel number 9, and you got about 1/9 tan t square plus 9 secant of t square. Then this one is about tan t. So we multiply cosine t to the power of 3 on numerator and denominator. So you got about sine t cosine t this one you got about sine t. This one we can put about, we have sine t, we do about factorization. So we have cosine t square. So in this situation we can put about 1 minus, sorry, that should be about cosine t. So that should be about 1 minus sine t square. So we can do about substitution. So we put about z equal to sine t, dz equal to cosine t dt. So we got about the new one. 9 multiplied with number 1 and 9 multiplied with z square. And we got a final answer. About z, that should be about side t. About t, that should be about this one. So we put about t equal to r times of h over 3 in here, here, and here. This one you can do by yourself. Number 16, we put about u equal to sine theta. Oh, sorry, wrong. Cosine theta. So you got about du equal to negative sine theta d theta. Because we don't have the negative, we put negative in here. So you got about negative du over u square plus u minus 2. About this one, we can do about factorization. So we put about u plus 2 minus u minus 1. Two minus 1, you got about positive number 1. 2 plus 1 is about 3. So in here we need to put about 1 over 3. U plus 2 divide u plus 2, you got about 1 over u minus 1, and we have negative 1 over u plus 2, and we got the final answer. About u, that's about cosine theta. So we change this one and this one with cosine theta. So this one you can do by yourself. This one we put about u equal to sine s du. We got about cosine s, the s. Next, we need to change the powers in here. If s equal to number 0, so you got about u equal to number 0 in here. If s equal to p, so u should be about 0, because two bound they have the same value 0 in here. The answer for number 17, that should be equal to 0. And the last one, we put about u equal to the square root of s. The u equal to negative the s over the square root of s with number 2 in here. Because we don't have the negative and number 2, so we put about negative 2 du equal to the s over the square root of s. We need to change the powers. So s equal to number 1, u should be about number 1. S equal to number 4, so u should be about number 2. Because we put about number 1 and number 4 in here. Square root of number 1, you got about 1. Square root of number 4, you got about number 2. The square root of s, we change for u. We got about cos of u. So we have the s over the square root of s. So you got negative 2 du. So you got about negative 2 sine u, sin u, sorry. And we have the powers in here. So we put the powers in here. That's it, the end. Thank you for watching. And here is a full picture of everything.